In this example, we're going to be adding two rational expressions that have different denominators. I chose this example because the second fraction doesn't have a denominator. And it's really confusing, potentially, because it looks like there is no denominator, but actually there's a denominator of 1. So I'm going to give you what not to do. Don't try to do this and give an answer and say that the answer is 9 over x plus 3. This is not allowed. You can't just say, oh, 2 is the numerator, add it to 7, because really there is that hidden 1 underneath the 2. So we still need to find a common denominator before we can properly add our fractions together. So I want to find a way to have a common denominator here. So off to the side, I need to find a least common denominator. The denominator on one fraction is 1. The denominator on the other fraction is 3. Luckily, the 1 doesn't matter so much, and since we have just one of these x plus 3's, our LCD is going to be x plus 3. So that one's pretty easy because there's only one unique term. That term becomes, well, one unique factor. That factor becomes our LCD. So I'm going to end up saying something plus over x plus 3 plus something, and we need to have an x plus 3 denominator. Out of habit, I wrote parentheses. You actually don't need the parentheses down there. They still are the exact same. So what did I do to the second fraction? The first fraction already had the least common denominator, so nothing to change there. The second fraction, though, it did change. I multiplied the denominator essentially by x plus 3, because x plus 3 times 1 is x plus 3. But whatever we do to the denominator, we have to do to the numerator so that we keep our same ratio of basically 2 to 1. So if I multiply the denominator by x plus 3, I need to be fair to the numerator and multiply it by x plus 3 as well. So the second numerator is now 2 times x plus 3. Like in our other examples, when we were adding fractions with the same denominator, I could eventually, once I had the same denominator, write everything over one single denominator, x plus 3. And then with addition, I can just slide all of these numerators, basically taking all of this and making one single numerator. 7 plus 2 times x plus 3. Now, another common mistake is that students will see an x plus 3 in the numerator and an x plus 3 in the denominator and start canceling out again, which we don't want to do. We need to factor before we do any sort of canceling, and we haven't factored yet. So let's go back to cleaning up our numerator here. Our denominator is x plus 3. We want to simplify as much as possible. Simplifying means getting rid of parentheses. So 7 won't change. It's not next to the parentheses at all. But now we can distribute to get rid of these parentheses. So we'll add 2x and we'll add 6. All right, next step, combine our like terms. We're trying to simplify. So we have a 7 and a 6. Those are like terms. Nothing else has an x in it, so it looks like 2x plus 13 is our numerator. And haven't done anything with the denominator, so we keep it as an x plus 3. So can we do any factoring to simplify? 2 does not go into 13. Well, I guess it goes in 6.5 times, but we don't like to have little decimals when we're factoring. We want to keep with integers. So the numerator can't be factored, and nothing can then cancel with denominator. So here we are. We're done. We have added two rational expressions that started off with different denominators, and more uniquely, we had a a single integer that was being added to a fraction.